Hi, everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science podcast. This is episode 35, and we stream this one live on February 28th. My name is Chris, and joining us, like every single week, is Heather. Hey there, Heather.
Hello there, Chris.
Hey, Heather. Happy science to you.
Happy science.
Hey, it's our video version today. You want to tell people what we have coming up in this very special high-definition SciByte?
Sure. Today we're going to take a look at the aren't they traveling faster than the speed of light neutrinos, a legged squad support robot that is awesome and frightening, the science of leap year, tornadoes on the sun, spacecraft updates, and always take a peek back into history and up in the sky this week.
Oh, I always love the Up in the Sky segment. In fact, I don't have the best memory in the world. So it was just a couple of days ago, I was in my kitchen doing the dishes, and I looked out in the sky and I saw the moon and two bright objects. And I ran back to my computer and went to the SciByte show notes and scrolled down to the bottom of the show notes, like, there it is. That's what it was. So it's always my favorite part. All right. Well, I don't have anything major to cover in the top of the show. If there's anything you want to cover?
No, I think video.
All right. Then let's do the SciByte news. Man, it's so official when we get to that. All right, Heather, what's the first news item for today's show?
The neutrinos. We've covered these a couple of times before. When they first came out, and there was a first experiment that said that they got to they shot off the neutrinos and it got to the other end 60 nanoseconds faster than they thought it should. Right.
Which
means it's traveling faster than the speed of light. They repeated the experiment, same thing. Another group of scientists came out and said, no, in order to travel faster than the speed of light, you'd have to produce a certain radiation, which isn't there. So we don't think you're actually doing it.
Mm-hmm. Mm-hmm. And you were skeptical because we actually covered this in SciByte like 17 the first time we covered it. And I believe that you were mostly wearing skeptical pants in SciByte 17.
Oh, I was super skeptical. In fact, people came back and they were kind of like, what do you think you're being so mean about?
Yeah, you kind of got some crap for it in the email.
I'm sorry. I was so mean.
All right, so what's going on with this?
So now what's happened is they were going back and they were looking at some of the equipment, and there was a loose cable somewhere.
What?
That they tested it to see how fast the data went, and they plugged it back in because it was a little bit loose, secured it tight, and then tested the data speed again, and it was 60 nanoseconds.
That seems really convenient. I mean, but I guess that would happen, right? Because if you had a loose connection, maybe data wasn't firing just right, and so maybe time sync would go out or something like that. I guess that
it was
would
the type of thing that it was relaying the GPS signals.
Oh, okay.
So it was syncing the clocks, which was originally, my skeptical pants was blaming equipment.
Right,
because that's generally what I fall back to. At work, if there's something too good, then I'm like, all right, check the equipment and then check it a third time and then get somebody else to check it. So, the high class, this kind of a center like the CERN, you're going to expect certain things are okay. So this is kind of a thing that caught them probably by very much surprise.
Yeah.
So, but the amount of time that it took for the data to travel the length of the fiber, was the exact timing that they thought it was going faster than the speed of light up. Now, another odd glitch that I read about that I hadn't really been aware of was that there was another error that they had to correct for.
Oh,
that
really?
would actually increase the speed. So there's something that's slowing down the speed, something that's speeding up the speed. So, of course, they're going to have to repeat the experiment. They obviously were going to repeat again, but now they need to repeat with all the equipment happy. They're going through making sure everything is right in order. They'll repeat the test. There are other stations elsewhere that are going to repeat the test. So once it happens in multiple locations, they'll kind of have a better idea that, this one piece of equipment is doing something else, another center will have something else going on.
Kind of funny though, right? I mean, this is a pretty fundamentally epic discovery.
Yeah.
And a loose cable? I mean, really?
Yeah. Well, if you break it down, the original scientists were, they are saying, we were kind of skeptical. We were kind of surprised this happened.
Right, yeah. Yeah, it was a big deal.
Yeah. And sometimes it is more of the, hey, guys, here's our paper. We didn't expect this to happen, and it did, we're trying to sort it out. You guys take turns too.
Right.
And so, and they say now it really was that. Exactly how you word things and exactly how media picks it up and how it spreads around on the internet are two different things.
Yeah, that's absolutely true.
So it's kind of a step back and saying there is a good reason to have skeptical pants on.
Yeah, you were right.
I was listening back to myself and I was like, yeah, I was blaming equipment. I was blaming time. You blame all the major things that it could happen.
Right.
GPS, the satellite timing, the location, exactly how far they are.
That's funny.
Equipment. So it's basic things that you'd obviously blame. So it's not like I was, bulb shining over my head.
No, now I follow what you were saying earlier on the pre-show. Is we should have gone through and got like a clip highlights of what we were saying back then and chop and put it together, right? But that would work better in the audio version. But
taking bits and pieces out of myself saying that, I kind of felt that was kind of cheating. I mean,
you were right though.
Well, yeah. Like I said, I'm not trying. It's not one of those things that I am awesome. It was just I was being skeptical about the things I would be skeptical about for anything.
Right. Yeah. No, I follow you. Well, any other thoughts on that one?
No, it's just it continues to be the back and forth, and a lot of people are just gonna wait until it happens at multiple.
I want it to be true. I really want it to be true because I always feel like whenever we break these laws that we've set, like this, the speed of sound or something like that, the sound barrier. It just seems like it makes the way for potentially faster space travel one day. I know it's kind of ridiculous of me, but I kind of feel like if we can figure out, if we could lick some of these things, then maybe we could actually get somewhere one day.
Well, maybe break our whole physics understanding and, understanding of the whole universe. If you break that and shatter it like, a dropped light bulb, sure, that's fun, but,
That's the kind of fun I was looking to have. That's all. All right. Well, why don't we go to our next news story then? What is it? I don't even see it here yet.
Leg squad support system.
Oh, that's right. The freaky one. Yeah.
This has some videos that are freaky and awesome.
I scrolled down too far. I see it. Okay. Yeah. Okay. All right. Tell me about this.
Okay. So, military personnel, they have to have a lot of equipment.
Yeah.
They're carrying 100 pounds of gear. And in the field, if you're carrying 100 pounds of gear and you're having to be sneaky and you're having to do all this stuff, it can be a little tricky. And also, you get to the end of your, where you're going, your destination, a little bit tired for carrying 100 pounds of gear. Even, big, strong people that have much more horsepower than me.
It's tiring.
So, yeah. And so what they've done is they've been working on, a little robot that it's like a dog, kind of like a dog horse type thing. That they have 4 legs. Probably have seen it on the video, and it's just kind of walking around. And so this thing the latest version can carry 400 pounds.
Wow.
Travel 20 miles, just 24 hours nonstop.
400 pounds.
Yeah.
That's pretty significant. Now, I think I had seen this a while ago, but I don't think it was up to 400 pounds. That sounds like a big improvement.
Yeah, this has been. There's oh goodness, now I don't remember who did Big Dog. That was like the first version of this.
Right.
And it had, slipping on ice and, correcting for itself. And the DARPA.
Yeah, DARPA, that's right. Yeah.
DARPA the Defense Advanced Research Projects Agency, came along and they said, yeah, that's awesome. Let's scale it up. Let's make his big brother. Let's make his super big brother on steroids.
Not the Star Wars walker. Not that big.
No, not quite that big. But
yeah,
so they've made it, and it can navigate terrain, so it can sort of correct for itself. That it has a little internal brain that says, if you're walking in water, if you're walking in mud, if you slip on ice, sort of how to correct yourself and stay upright. And this kind of thing. And what they've done is they've put in little eyes inside it, little cameras, and it can follow a leader. It can travel to designated GPS coordinates.
Oh, boy.
And so it can navigate itself. So it can tell trees, rocks, obstacles, people.
Sand, apparently. We're watching it walk through sand right now, yeah.
Yeah.
Huh.
And so it can tell what's there, know how to navigate it, and travel either by following someone or by, you plug in a specific GPS coordinates and it just goes there.
Oh, now you have a video here that shows sort of the evolution of this. So yeah, these are some of the earlier ones we've talked about, and then as the video advances, you see the more. Geez, yeah, it's gotten bigger and bigger.
Yeah,
huh?
Yeah, I really like that video because it shows, the steps, of all the different kind of versions that are there. I think later in the video, there's like the little baby type version that just like falls over.
Yeah.
Trying to climb a hill.
Yeah. It's kind of, in a weird, creepy way, a little adorable in some circumstances.
You really get into the creepy part where the same people that made the first one made a little two-legged walker, and it's like a little person running and walking, and that's kind of creepy.
Yeah.
It's cool.
It just fell.
Yeah. Some of the ones fell because you know what? You don't always get the programming right the first time.
Right. No, totally.
So it's kind of interesting to see, they did it this way and they made it that way and it fell here and it can't survive on the ice there. But, it's gotten smarter and smarter.
Wow.
And so one of the things they're adding is auditory, little microphone technology. So it can take commands. So if it's on a field exercise with a group of military personnel, then somebody could say, stop, sit, come here, and it will follow those directions.
Right.
Or you can tell it, follow, and it will follow you. And there's like two ways to follow you. One where it stays exactly on your track. It follows exactly in your footprints, essentially. Or it just kind of goes where you go and it kind of tracks its own way. So
it's like an MMO companion or something. It's like a little bot from a game.
Yeah. And so you can tell it, follow exactly behind me or wander off to the side 5 feet, and try to get in trouble.
Wow.
But it's one of the things where I read some articles and some people said, well, why don't you just do an animal? A dog, a horse, whatever.
Oh, yeah, okay.
Okay. But these kind of things do need food. They break legs. If a firefight breaks out, you can't jump behind them and be not as bulletproof as this thing. You sit it on the ground.
Yeah.
You can hide behind it.
Yeah. Yeah, and you couldn't you down the road maybe arm it too? Like if it has microphones and cameras?
Well, why not? Currently they have power sources on board, so it can, it walk itself. And what they can also do is you can go over and you can charge your radio on it.
That is awesome.
Anything that you have that they have battery for, they can go up and charge it up.
It's a portable charging station too?
Yeah. So it carries all your stuff. It's a portable charging station. I saw it and I thought, if somebody got injured, just throw them on top and they can keep going.
Yeah, no, seriously. Wow. Yeah. And you could power like little medical devices off this thing and all kinds of stuff. Like you could have a little unit that's just decked out in medical supplies and has all the power you need to run that. Oh, that could be awesome.
Yeah. So, you can go the way where it's, a little armed, something, or it's like, a walking medical station, or there's all kinds of ways you can do this. But watching the videos, I just watch these videos and I'm like, that is awesome. And a little scary.
Man, the government gets all the good toys, Heather. They
go out and they say, hey, everybody, we are interested in this kind of stuff. And then everybody says, look what we can do. And then they give money to the people who are awesome. And these guys were awesome. So
yeah, this video just showed it offload itself from a plane and carry its gear with it. Talk about a huge boon for, obviously they're using it for military things like soldiers in the field and stuff, but just in general, I'd love to have one of these things around the house. You have
to be a little bit smaller.
Yeah, and it has to have an override command of some sort. They've got to build in some sort of do no harm programming into this thing. Because it looks like it would just never give up. It would just keep coming and never stop. So that's a little scary.
Just want it to follow you around with drinks.
Oh, that is a great... That power could be used to power a fridge, and he could walk around with beer and soda pop in there and all kinds of things. It's the ultimate guest machine.
Yeah, see, I knew you would either do that or something that could either walk around in a little gripper. So, grab a kid.
Oh, I like that.
To you.
I like that, too. See, I like that. That's a good idea. Yeah, a little kid sitting. Any other thoughts on that story?
No, this thing... For videos, this thing is just awesome.
Yeah.
Just watching this and watching how it's progressed and what it's done.
I bet it does. The chat room, Cheese Bacon in the chat room says, I bet it runs Linux, and I bet it does too. Yeah. All right. Well, why don't we take a quick pause here before we go on to our next story? And we don't have a sponsor this week, but that sponsor can be you out there, audience. If you go over to jupiterbroadcasting.com before you buy and scroll all the way to the bottom of whatever page you happen to be on, you'll find affiliate links for Amazon US, UK, Newegg, ThinkGeek, Best Buy, Mint.com, and my favorite, Audible.com. I love Audible.com. I'll have a book pick probably for you guys next week. But before you shop at one of those places, we get a little percentage of your purchase if you buy it there. And also, I should probably start reminding folks about the Jupiter Signal because it will be coming out mid next month. And you can grab our monthly newsletter. It tells you all kinds of details about Jupiter Broadcasting and what we're up to over at bit.ly/Jupiter Signal. And I'll also try to include a spot where you can sign up in the show notes. But yeah, the Signal's great because it's sort of like a once a month thing, so you don't have to worry about us overwhelming you or stuff like that.
Yeah.
All right, Heather. Well, why don't we move right on? Boom, 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 to part 2 of the SciByte News Bite. What's our first story? Science
of the leap year.
Oh, today interesting.
We're recording this on the 28th of February, and tomorrow is actually the 29th. We don't see these come around too often, but it's more than just, once every 4 years. There is thought process to the whole thing, and some of the things I didn't quite realize. And they were pretty cool.
All right.
So, kind of break it down, day is sort of on the simple boiled down version. A day is how long it takes for a star to appear in the same place, after a rotation of the Earth.
Mm-hmm. Okay.
Which is technically 23 hours, 56 minutes, and 4 seconds. So not quite 24 hours. But what happens is the Earth, in that daytime, travels 1 day forward in its orbit. And so it adds another 3 minutes, 56 seconds.
Okay.
And that add up to be 24. So so there's multiple geometry things going on here.
All right.
Science and math combined.
No, I like it. Actually, I never really quite understood that process. So that makes some sense. It's a little confusing, but it makes sense.
It's okay. So, and the orbit of the Earth, not exactly completely circular.
Right.
So if you go through and you take a whole bunch of different years and you mark it down to, aligned so that noon on December 21st is all the same, kind of. Or one rotation around the sun, one full orbit. It kind of averages out to 365.2423. So it goes on, which is 365 days, 5 hours, 49 minutes, and a handful of seconds.
Okay.
So once you add a day every 4 years, you can keep the calendar aligned so that noon on December 21st, the solstice, always is the same. So that's what this is about, somewhat. It's about keeping the solstice aligned up.
Ah, all right.
So they're kind of doing that to keep the calendar, stationed around one point. And so, you add one day every 4 years, and that gets you a little bit closer. Now, to get you even closer to the exact year, the average, every 100 years is not a leap year, but every 400 years is. So it's once every 4 years, unless it's divided by 100, then it's not. But unless it's able to be divided by 400, then it is. So some of these rules are kind of weird. This was something related to Y2K. They actually brought this up, is that it would have been calculated incorrectly.
Oh.
Because it's a 100 year. So it shouldn't be, but it's because it's divisible by 400, it actually was a leap year. So there's multiple rules going on, and 2000 was one of those that was kind of kooky and weird. There's been a handful of those years that are like that. And it's just it's all about keeping the solstice aligned, and all the different little rules, like the 100 years isn't, 400 years is. Those were kind of things that I didn't quite realize, and kind of interesting to tell people. Anytime somebody this week mentioned leap year, I'm that's in my brain. I'm
did you know?
I should look cool and awesome and really smart if I'm Hey,
I like that that's your version of looking cool and awesome.
why not?
Yeah, totally.
Okay.
It's
Maybe
one of
just
these
the news.
things in our culture that we just do without really thinking very deeply about. Like,
Yeah.
another one that's a lot more in people's faces, but it's not really the same complicated thing, but is like a daylight savings time.
Yeah.
It's one of these things that's just, we do it, and I never really thought very profoundly about it. I've honestly never really thought about leap year. I've always just been like, okay, this is a leap year. Okay, this one's not. And that's as far as I ever go with it. So it's kind of, it's a little confusing, but it's
I believe
interesting.
daylight savings goes back to when there was a much larger population farming. So you needed to shift it
Right.
so that
I've heard that.
Morning and sunrise and sunset needed to be a little shifted so that they can.
I've heard that. I've also heard claims it's for power conservation, but I've also heard that doesn't really balance out because it kind of, people just change their habits so that the power usage still remains the same.
Well, there have been presidencies where they've moved forward or back daylight savings so they can sort of shift the work day to more light based.
Right.
And so
I think it just recently was shifted by President Bush, but I don't know. Maybe people could write in if they have some insights onto that. SciByte at JupiterBroadcasting.com and let us know. All right, Heather. Why don't we move right on to the next story?
That's right.
This one involves the sun, doesn't it?
Yes, it does.
Mm-hmm.
The Solar Dynamics Observatory.
Say what?
Yep, you may not know it, but anytime we've had these giant coronal mass ejections and the little animated GIFs I put in the show notes that are really cool and awesome.
Yes, I love those.
This is where they come from.
Oh, okay. These guys,
this is satellite, and these people are where those kind of things come from.
Is this a satellite that's orbiting the sun?
It's orbiting the Earth.
Okay.
In a geosynchronous orbit, so it always has an uninterrupted view of the sun.
Oh, okay.
So nothing ever really gets in front of it.
Okay.
The Earth doesn't. And so, but on February the 21st, there was a partial eclipse. The moon got in its way just a little bit of the sun. So there's a little bit of a partial eclipse, which we seem is like, not so big a deal on the Earth. But for this, the sharp edge, because it's not through atmosphere, there is a very sharp edge between the moon and the sun.
Oh.
So they're able to use their instrumentation to see that sharp edge and how light reflected in its optics, how it went through the filters and the support grids. So they're able to kind of calibrate, the dark and light line inside their system so they can kind of get even more accurate measurements of what they're seeing.
So they use that partial eclipse as like an equipment calibration opportunity?
Yes, absolutely.
Interesting.
And on top of that, there was even a sunspot, an active region, blasts ultraviolet emissions into space. And the moon covered that very briefly. So they're able to see, the emissions and then the dip in the emissions. So they're able to calibrate the energy readings for this stuff too.
Oh.
So they're able to make corrections with all the
kind of see a before and after in some cases.
So they're able to make all the light corrections for the light bouncing around inside the instrumentation. They're able to kind of re-zero and calibrate the energy reading equipment.
Boy, talk about making lemonade out of lemons there, huh?
Oh, yes.
The sun's blocking our view of the thing we're studying all the time.
Awesome.
Yeah.
Yay.
That's impressive, really.
Yeah, and it's funny because they could actually see the little hills and craters if they look at the data, like the high def, essentially, in images. Yeah. Because there's no atmosphere to kind of blur the edge of the moon.
Mm-hmm.
They could actually see, there's a crater edge, there is a little hill. They could follow the exact profile of the moon from that. That was kind of cool. They were able to hey, look.
Yeah.
And, recalibrating and making things even more accurate for the future.
Right. I always think that stuff is always cool. It's just, it amazes me how these scientists are just the most ingenious at getting everything out of every opportunity and getting every bit of data out of anything blocking light or anything. Yeah. It's incredible. It's really impressive stuff. Well, that's why they're the pros.
Yeah. I mean, you think for any of this type of major study project, you're going to think of all the different things that could happen, all
Right.
the different things that could go wrong,
Right.
and then hand it off to somebody else and think of all the things they think can go wrong. I've actually heard, some projects or major things going to writers and going, hey, what are all the crazy things you think could happen? Not necessarily for any of these specific programs, but some studies.
We're about to do something we've never done before, and we need to try to think of every conceivable outcome. Can you help us?
Yes.
And that guy's always like, well, I mean, I'll just write some crap down. I mean, what's the worst that could happen? It's not like I'm going to get busted if it doesn't come true.
Those kind of things are, when they go to writers, I've heard it, it's very wild. It's kind of like, hey, what kind of crazy things could happen to the Earth or to this, or how many kind of crazy attacks and weird things that could happen. That writers are definitely out of the box thinking for that kind of thing.
If they came to me, I'd be like, here's what you got to worry about. Aliens. What you got to do is worry about aliens coming down and opening up your probe. You got to get, what you want to do is make sure that all of your NASA software is wrapped in DRM. That way the aliens can't pirate it. Just make sure your activation servers are online and can be reached by Mars.
Yes.
Yeah. All right. Well, any other thoughts on that story?
No, I do. I like these kind of things too, where you're going to use every bit of what you can, kind of use every contingency to say, we're going to recalibrate, we're going to get more data, we're going to figure out a way to use this to our advantage.
Right. Absolutely. Absolutely. All right. Well, then it is time for our spacecraft update. That's what the one up sound means, is spacecraft update time. And this one is about our favorite planet, isn't it?
Yes, it is. At least my favorite.
Oh, no. I'm claiming it too, because it's
okay.
If there's any ever chance I'm going to get to any other planet in my lifetime, which is there's almost a 0% chance I'll get to one. But if there ever is one, it's going to be Mars. So
true.
It's my fave.
Oh, okay. I didn't know if Jupiter was the auto.
Oh, well, come on. But Jupiter's just not even a possibility. That'd be like...
Yeah, you can't really land. You kind of float.
That'd be like saying I'm holding out for Scarlett Johansson or something. It's just not going to happen, right? I mean, but I, come on. It's just ridiculous. That's maybe if I can get to Mars and I'll just keep on going and there'll be some sort of miracle. But I'll wait to see. In the meantime, though, these landers get to have all the fun.
They do. This one we've kind of covered before, and not a lot of science. It's mainly just a really cool image. But so we've looked at it before, where we say, poor little Opportunity is having to bunker down for the winter. This is the first time that it hasn't been able to just work through the winter. But there's enough dust on its solar panels that it kind of had to find a little hill, park, and it's going to do science from there. And one of the major science things that's going to do is they're going to look at the radar, actually, of how it's going back and forth, so they can kind of get an idea of how the spin of Mars has changed over the years, so that they can say what the interior is like. Whether it has a solid core, some sort of liquid magma core, or things like that.
I'm surprised we don't already know that, to be honest.
Well, I mean, we're not there. I mean, for Earth, we can measure earthquake data.
Yeah.
You can see how the waves of the earthquakes travel through different spots. So you can, earthquake happens in one part of the world, and you have measurement centers on everyone else in the world, and you can sort of map out how the waves are bouncing around the Earth and how they change based upon what they're seeing. Is it dirt? Is it magma? Is it...
Magma.
Yeah, all the different parts of the interior of the Earth.
Right.
And so some of these, all we're really seeing is pictures and analyzing little scoops of dirt and scratching the surface and taking pictures, and all this kind of thing.
Yeah, I guess so, huh? It's not like we're...
delve in.
Yeah, right.
So we're able to get some of that data. And so within 6 months or so, they think they'll be able to have enough data to really get that.
So what do you gain by... I mean, other than just having a better understanding of Mars, which is always important, is there anything particularly useful that they gain by knowing if it's what kind of core Mars has? Yeah,
well... anything more than can find out about Mars really is our best option for Earth 0.5. The next, major update or patch to, if we have to fall back on something, it's the test server.
Right, totally.
If everything else goes down, it's the test server. It's going to survive.
Yeah, that's a good point. I suppose it's important to know at that point.
Yeah, if we move out of the Earth and we are able to colonize Mars or start changing it and terraforming it, then we really need to know everything we can about it. What kind of, core it has, how its orbit is changing, how its tilt changes, all these kind of things.
Right.
The more we know about it, the more we're able to build upon that knowledge to get us to aim for the future, to give us more options, and to really narrow down and get more answers.
Well, there you go. And this is interesting, too, because these are the old rovers, the older ones?
Yes, the old ones.
Yeah.
Where little Spirit was the one who,
wow.
In the last couple of months, finally stopped calling home.
Still kicking, though.
Yeah, but this one is the one, this Opportunity is the one that's still kicking.
Yeah.
This little rover has had all the luck.
Yeah.
Spirit landed first. There was a computer glitch. It had a little bit of issues. Its little wheel got froze. It got stuck in dirt.
Aww.
Opportunity, they were able to update the software before it even landed, so it didn't have an issue. This is the one that landed right in the little crater, so they were able to peek up and see all this, rock formations.
Yeah, they were really stoked about that. They're like, this is a great science project right here. I remember that.
It's like, we don't have to go anywhere. This is like, if we never travel farther than this, we'll find out tons of information.
Right, yeah, that was really cool.
Yeah, so it was like, hole in one there. It's kept on going. It's had, I believe it was the one that had a little dust devil travel over it, so it kind of sweeped its solar panels off again.
Now, you noted here, though, they've been doing some tilting, so that's helping, right? Yeah. So that's sort of making the dirt slide off.
Well, it doesn't slide off.
No, it's that thick, huh?
Yeah, Spirit did this. Well, it's not going to, slide off. If you have a little coat, this is not like sand. This is like dust. So if you just tilt something, it's not on a very small layer. The larger the larger pieces will roll off. Yeah, the smaller ones just kind of stick.
Right.
They're not going to go anywhere.
That makes sense. They need to take that robot we talked about at the top of the show and have it go out there with some dusters and dust them off. That thing could navigate Mars.
There you go. So the tilt is more about aiming the solar panels more towards the sun. So it's more direct aim, so that it can soak up more of the sun's power.
Did you see there was a story that came out today that NASA is sort of restructuring their funding so that way they can try to continue? So we'll probably talk about that in a future episode. But
they're playing a little. They're definitely doing the ball and cup game.
The shuffle thing, they're shuffling stuff around.
They're doing a little bit of a shuffle.
But it kind of, it really states how important traveling to Mars must be to NASA, because they're sacrificing other projects in order to continue sending. And they're kind of like, well, it's going to be robots. It's not going to be anything more than robots.
But there's definitely stuff for Mars. They want to do Mars. There's a lot of pressure from the public, from politicians. It's all very Mars.
Well, good.
They're going to try to do what they can to kind of shuffle the money around so they can maybe do specific projects.
Well, here's hoping, Heather. Here's hoping. Yep. All right, well, any other thoughts on that one?
No, just hopefully it'll live through the winter and we'll be able to continue on in the next Martian spring.
Absolutely. All right, well then hop on over here because it's time to jump into the SciByte time machine. Come on, Heather, let's go. Come on, here we go.
We're still going.
All right, where does the time machine take us today? What's the first destination of that time machine, Heather?
Okay, the first destination is going to bring us back 143 years.
Ooh.
March the 6th, 1869.
All right.
This is when the first published version of the periodic table of elements was put out.
Aha!
I actually talked about the periodic table in a very early SciByte, so they originally published this out, and he kind of figured out there is a method to the madness of what row and what column everything is in. It's speaking about specific things, orbital levels of electrons, the mass. So there's a lot of things in the periodic table that just the location can tell you a lot about it.
SciByte episode 10 is where you cover the periodic table.
Yes. And so this is the first published version. Now, what was interesting is he published this and he kind of left gaps. Very specific gaps in the table.
Aha, very smart.
Based upon this, well, he saw the map, he saw the grid. He said, this goes here. Now this one has to go here. There's something in the middle. I know the basic properties of what it's going to be. We haven't found it yet, but this is what's it's going to look like this.
Right.
And he was right. He left those gaps, and that's, the element that goes there kind of fits in what he thought it should. So he's kind of, filling it out and Mad Libs, putting in circles and saying, this is what it's going to be. And sure enough, later, it was.
That's pretty impressive. That was 143 years ago, which is not bad. All right, well, our next one takes us to 62 years ago, March 6th, 1950. What happened then?
This is when everyone went, woo-wee, and all moms with carpets went, oh no.
And hair got in your hair.
Silly putty.
Yeah. Best thing with silly putty was putting it on the newspaper, then peeling it off and getting some of the newspaper print on there.
Yep, reading it, pretending to read it backwards. So this was, this is when it was marketed. The first day when it was marketed and put out, little rubber-like material and plastic eggs. Right. Stretched, rolled, bounced, like you said, newspapered. What's interesting is it was originally discovered in 1943, 7 years earlier. Who was combining silicone oil and boric acid. It was at the General Electric's research company, and they were just trying to make synthetic rubbers.
No kidding.
And they saw this, and they're like, no application that we can really see. So it was passed around the office as like, hey, look, kind of funny what we made, huh? And somebody saw it and went, I could totally sell this. And he did, and it made him a millionaire.
So I on the video version here, I'm playing the original Silly Putty commercial that the looks that came out back in the day. It starts with like a military guy smoking, talking to the children about how great Silly Putty is, and he's demonstrating its great versatile usage. I mean, you just don't have commercials like this anymore for Silly Putty. Wow.
Oh man.
So there you go. So that you look at that video. It sure looks like a long time ago. All right. Well, that's what's happening in the past. That means it's time to look up into the sky, isn't it?
Yes, it is.
All right, what do I have to look forward to this week?
So February 29th, our leap day, is the first quarter moon. So that's when it's a quarter full. And then we get back to our planets. Jupiter, Venus, Mercury. On the 1st, they're all in a line to the west-southwest, about an hour after sunset. Jupiter again is up top. Venus is the brighter one, but Jupiter's up top. And then Mercury is a little bit harder to see. You might be able to see it's close to the horizon.
Okay.
And then March the 3rd, Mars is at opposition, which means the Earth is between it and the sun. So it's kind of in the middle. It's the sandwich in the middle.
Yeah.
So it's a pretty good viewing then. It'll be in the east towards twilight.
Okay.
In general, Mercury is right at the sunset to the west, to the lower right of Venus. So it is going to be harder to see. Venus is definitely the bright guy. He's the brightest one. Jupiter and Venus are still, hanging out together and getting closer and closer. Right now, they're going to be about 10 degrees apart. They're going to get that close this week, which is about the size of your fist, held at arm's length. It won't be big. So, like holding towards the camera.
Okay. All right. I got it. So
that's about 10 degrees.
Okay.
So they're going to end up about that close to each other.
Okay. All right. I got it. Well, that's exciting. Little planet party up there.
Yep. Jupiter's still top dog. Jupiter's going to be the highest one all week.
Right on, Jupiter. Right on.
Woo!
That's my ScarJo of the planets. Well, there you go. I think that's just about brings us to the end of this week's SciByte, isn't it?
I think so.
All right, everyone. Well, so everybody probably knows the details on SciByte, but here's the way this show works. 3 weeks a month, we have an audio version, but you can download a video that sort of has a visual guide that goes along with it. Yeah. And you can also tune in over at jblive.tv every single Tuesday at 7:30 p.m. Pacific. And then on 1 week a month, the last week in the month, like this one, we do a video version of SciByte because it's fun to do something where you can see our faces. We get a little more visuals in there, and everybody likes that. So yeah. All right, Heather. Well, thanks for the great show.
Yeah, and don't forget, if you have feedback or story ideas or questions about the show, go ahead and send them in. You can even do a video, and we'll get you included in the video episode.
Oh, yeah. That's always encouraged. We had some last time. That was a lot of fun. Yeah. So email those in SciByte@jupiterbroadcasting.com. All right, everyone. Well, thanks so much for tuning into this week's episode of SciByte, and we'll see you right back here next week.